In a world where oil spills happen every day, two scientists are left to investigate and find efficient manners to clean them up. Brandon Wong, the mad genius, and Henrique Neves, the glorious chemist. Together, they will answer the question: what is the effect of the amount of ferrofluid on the efficiency of a neodymium magnet in the separation of oil from water? They must find a way to save the world, lest it turn to turmoil.
Today, they're experimenting with ferrofluid in oil. But how will they do it?
Ferrofluid is a liquid which has tiny magnets in it that are called nanomagnets. When the ferrofluid mixes in with the oil, it makes the oil magnetic, because the nanomagnets blend in as well. However, the oil and the water do not mix because they both have different densities.
Now, because the oil is made magnetic by the ferrofluid, a strong magnet like this neodymium magnet should be attracted to the ferrofluid like this.
They hypothesized that
If the amount of ferrofluid increases, then the efficiency of the neodymium magnet in the separation of oil from water will increase.
nearly all of our materials are common household items, so this experiment is low cost.
You will have to buy many of our main materials, which include ferrofluid, a neodymium magnet, mineral oil, petri dishes, pipettes, water, food coloring, a graduated cylinder, and paper towels. Lots of them.
To prepare, fill 1 cup with water and another with mineral oil. Add 2 or 3 drops of any color food coloring to the cup of water and mix to create colored water. This will make it easier to see the water. Prepare paper towels to clean up any messes, and use a spare cup to discard fluid. Fill the petri dishes with about 14 milliliters of water each. Add exactly 2.5 milliliters of mineral oil to the petri dishes using a graduated pipette.
The petri dish without any ferrofluid is your control. Add 1 drop of the ferrofluid into the oil. Wait 1 minute and do not stir. Place the neodymium magnet in a corner of a plastic sandwich bag and slowly swipe the magnet just above the oil. Carefully transfer the excess liquid to the graduated cylinder. Measure the amount of oil on top of the water. Repeat with varying amounts of ferrofluid 3 times for each amount and use a different petri dish and plastic bag for each trial. Once the experiment is finished, clean up the workspace, analyze the data, and calculate the efficiency of the cleanup.
Notice how the ferrofluid and the oil were both pulled away together from the water when Brandon swiped the magnet over the mixture.
Upon analyzing their collected data, they concluded that the more ferrofluid they inserted into the oil, the less oil is left over post-cleanup.
Although adding more ferrofluid resulted in less oil, the efficiency decreased when using 5 drops instead of 1. In order to get the most out of a cleanup, a moderate amount of drops must be added, or else some drops may become unnecessary. Some errors that may have been made include fluid spilled and inconsistent amounts of fluid due to pipette and graduated cylinder estimations.
These two scientists have figured out a solution. They have used nanotechnology to their advantage, and most importantly, saved the world as we know it. Through just a small experiment limited within the confines of a lab, a brilliant revelation unfurled. Nature, climate, and people will be further preserved through the years to come. They have remained loyal, surpassed toil, and separated oil.